Unit 3, Section 5, Part 2. We're going to talk about the tricky ones, vertical lines and horizontal lines. Remember, their slopes are weird, so their equations are weird. A vertical line is written in the form x equals a, where a represents the line's x-intercept. Okay? The way that I think of this is that if it says, okay, like it does here, if it's going to be x equals a, that means x is always a. So that the equal sign and the is always is the sentence way to say that. So no matter where that line goes, the x part of it is always going to be whatever that number is on the other side. So, and the best way to define it is with its intercept. Because if you start at the origin, you go over, and that's where it intercepts. It's negative 1, 0. Okay, well, if I go up here, sorry, not negative 1, positive 1, 0. And if I go to this point, it's 1, 2. And if I go to that point, it's 1, 4. And if I go to that point, it's 1, 6. And if I go down here, it's 1, negative 2. And if I go down there, it's 1, negative 4. And notice that x is always 1. So this is going to be, oh, hello, look at that. I was using the wrong line. No wonder I thought it was a negative 1. All right, so this is the line in question. There we go. And that is negative 1, 0. There we go. And that is negative 1, 2. And that one is negative 1, 4. And the pattern continues negative 1, negative 2, negative 1, negative 4. But if you notice in all of the points, x is always negative 1. Now, slope is an interesting deal here. Remember, slope is rise over 1. Y is on top, x on bottom. So we're going up constantly, right? So we could say that the slope is m equals 1 over, and then we don't go any left and right. So that's undefined. Vertical lines are always going to be an undefined slope. Now, horizontal lines, and this is a weird thing about them. Vertical, you think of as the y direction, but it's talked about as an x equals because x is always a number. It's the reverse of that for horizontal lines. It's a y equals. So what's that saying is y is always a, whatever that a is. Here's the line we're looking at. So 1, 2, that's at 3, 0, sorry, x and 3. This would be at 1, 3, 2, 3, 3, 3, 4, 3, 5, 3. Actually, that's not how that counts, is it? Yeah, it is. 2, 3, 5, 3, 6, 3, negative 1, 3, negative 2, 3, negative 4, 3, negative 3. They're all 3. So y is 3. Now when we look at slope here, and when you rise over run, we are rising none, but we are running by 1 every time. So that means 0. A slope of 0. Okay? So let's graph each line. Well, if you look at this one, if you said y equals mx plus b, there is no mx part. There's just b. 1, 2, 3, 4. And it says y is always 4. So everywhere that y is 4, we can put a dot. And it's a horizontal line through y is 4. Okay. X equals negative 2. Well, you can't do y equals mx plus b because it's an x equals. But it's saying x is always negative 2. So where is x negative 2? Right here. Go 2 to the left. And then it's always negative 2. And so we graph y equals, or x equals negative 2. Now, y equals 0. Well, we're talking about the y, but we don't go up any. We go 0. So y equals 0 is another way to talk about the x-axis. Goes right through there. Okay. So vertical and horizontal lines, finding their slopes and writing them in slope-intercept form, that's not really how that works, especially those vertical lines. It's an x equals, not a y equals. Now, we're going to put those things together that we talked about, parallel and perpendicular. Parallel, remember, same slopes, right? Perpendicular, negative reciprocals, opposite and flip, right? So determine if they're parallel, perpendicular, or neither. Well, when it's in slope-intercept form, it's very easy because the slopes are right in front of x. If the first one's 5 and the second one's 5, that's same. That means they're parallel. Okay. Let's look at 19. You've got negative 2/3, or negative 3/2 and 2/3. Well, they're different signs, so that's opposite, and they're flipped over. So that means they're perpendicular. Now, when we get to 20, it's a little trickier. We don't see the slope right away. We have to solve for y equals. We got to get that slope-intercept form. So I'm going to take the first one, and I'm going to subtract x, both sides. So I got 2y equals negative x plus 2. And I'm going to divide by 2, everybody. So that's y equals negative 1/2, because that's a 1x, plus 1. So now I just need to know what the other one is. Well, let's move the 6x. Negative 3y equals negative 6x plus 21. Divide by negative 3. Everybody. Y equals. Negative goes positive. 3 goes into 6 2 times. Minus 7. Doesn't matter what the b's are. It matters what the slopes are. They're different signs. And I could turn this into a fraction by putting a 1 under it. They're flipped over. So this is perpendicular. And if you forgot the symbols, perpendicular is this symbol. Parallel is that symbol. Put the symbols on here too, just to remember. All right, give it a pause. Try 21, 22, and 23, and let's see what you can come up with. Are they parallel, perpendicular, or neither? All right. The second equation here in 21 is already in slope-intercept form, so we just have to move the x, and then we're going to divide by 1. That's negative on everybody, so y equals x minus 9. They have a slope of 1 each. That's the same, so those are parallel. 22, we've already got one of them. We just need the other one, so let's move that 3x. Negative y equals negative 3x plus 2. Divide by negative 1, everybody. Y equals 3x minus 2. Now, if we put that as a fraction, okay, flip it over. They are a flip over, but they're not different signs. One's not positive, one's not negative. So this is a neither. And I would definitely check my math on those just to make sure. Now, if we look at 23, we got to solve both of them. So let's move that 4x. Negative 6x equals negative 4x plus 12. Divide the negative 6. X equals negative makes positive. 2 goes into 4 2 times. It's into 6 3 times. 6 goes into 12 2 times. Move that 3x. 2y equals negative 3x plus 10. Divide by 2, everybody. Y equals negative 3/2 x plus 5. Different signs, flipped overs, perpendicular. That's what you should have got. All right. There's a few more sets of these. Go ahead and give it a pause. Work it down to 27. Come back, let's see, and then I'll show you 28 and 29. All right, 24. First one's already done for us. We just have to move the second, so subtract that 2x. 8y equals negative 2x plus 56 divided by 8. y equals negative 1/4 x plus 7. They're the same, so parallel. First one's done. The second one we need to do, move that 12x. 3y equals negative 12x plus 27. Divide by 3. Y equals negative 4x plus 9. Yep. They are the same, so parallel. Now these ones get tricky because it's y equals 7. Okay, so if I graphed that, 1, 2, 3, 4, 5, 6, 7, and it goes through up here, and x equals 2, 1, 2, it goes this way, and let's see, the y equals 7 has a slope of 0, and the y equals 2 has a slope that is undefined, which is actually a 1/0. They're flipped over, and it doesn't matter if they're opposite signs because 0 is not positive or negative. So these are perpendicular. If you see one that's undefined and one that's 0, or if a line is a y equals and the line is an x equals, then they are going to be perpendicular. If they are both same variable equals number, x and x, or y and y, they're going to be parallel. And I could graph it and show you. 1, 2, 3, 4, 5, 6, 7, 8, 9. Go straight up and down. 1, 2, 3, 4, 5 back. Go straight up and down. They both have a slope of undefined, so the same slopes are parallel. Now let's look at these last two. I'll do 28 with you, and then I'll let you try 29 on your own and come back and check. So which line is parallel to the line shown below? Well, there's our clue word. Parallel means same. So which one has the same slope? Well, we need to know what our slope is. So let's count it. 1, 2, 3, 4 up. 1, 2, 3 over. So our slope is 4/3. So we need something that's going to have a 4 with the x and then divided by a 3, and it needs to make a positive. So if I need a 4 with the x, because it's going to have to be the y part that's on top, if I move this 3x, that means it's negative 3x. I don't want 3 on top, so it ain't that one. If I move this 3x, I don't want 3 on top. It ain't that one. So it's either C or D. If I move 4x, it's a negative 4x. I need parallel to be same. If I divide that by a positive 3, I'm going to get negative 4/3. That's not the same. But if I do negative 4x, I do negative 3y equals negative 4x plus 15, divide by negative 3, negative and negative makes positive 4/3. So I'm going to go with D. Go ahead and pause it. Try 29. Remember, perpendicular means opposite reciprocals. Okay? Change it, flip it over. So they need to be different top bottoms, flipped over, and different signage. Give it a try. Come back and see. Okay, here we go. Down 1. Over 5. My slope is negative 1/5. So what I'm looking for is 5/1. I want it to be a 5 on top, which means it has to be a 5x. So I'm going to say C and D are out because that's only one x. But let's move these guys. Now you have to be careful depending upon what the numbers are in front because you may divide down to the 5, So, but it can't be smaller than 5 because smaller than 5 divided by anything is going to be 5. So let's see about A. If I move that 5x, I've got negative y equals negative 5x plus 3, and I divide by negative 1. Gives me y equals 5x minus 3. That's a match. I'm going to go with A. Let's check B just to be safe. We subtract 5x. Y equals negative 5x minus 7. Negative is not what I'm looking for. I want opposite of negative, so it has to be A. And that's what we're doing with parallel and perpendicular. Parallel, same slope. That's what it means. What happens is then they don't touch. Perpendicular, opposite reciprocal or negative reciprocal slopes. That's what it means to be perpendicular. What happens is they intersect at 90 degrees. Okay?